So let's solve this equation. Tangent squared beta equals 1. Given that negative pi is less than or equal to beta, which is less than or equal to pi. So we need something between 0 and 180 degrees. Sorry, negative 180 and 180 degrees. So we got to consider the negative options. I think the question said something about factoring. We could subtract 1 from both sides and then factor it like x squared minus 1. Yeah, let's do that. Let's do what they say. Tangent squared beta equals 1. Subtract that 1 from both sides to set it equal to 0. That's how we solve equations by factoring, right? Set it equal to 0. And look, if you had x squared minus 1, you could factor that to be x minus 1, x plus 1. Same thing over here. I'm going to factor this to be tangent beta plus 1 and tangent beta minus 1. And then set each factored piece equal to 0. So you get tangent beta plus 1 equals 0. And we have tangent beta minus 1 equals 0. So if you solve each of those separately, you get tangent beta equals negative 1. And if you remember, tangent is the opposite over the adjacent. So that means the opposite and the adjacent sides have to be the same to make it equal a 1 or a negative 1. They have to be the same number. So that's a square root of 2 over 2 triangle. And you'll get the same thing over here. You get tangent beta, just positive instead of negative. So those are 45-degree triangles, because that would give you a square root of 2 over 2 and a square root of 2 over 2 over here. So 45-degree triangles everywhere where tangent is both positive and negative. There's 4 different places there. And it needs to be, we need to consider negative and positive. So let's do the first positive ones between 0 and pi. This is 45-degree angle is pi over 4. And then here is a 3 pi over 4. And we're not going to keep going around the circle because the restraints were between negative pi and positive pi. So let's go backwards. Let's use a negative pi to rotate us this way. That's negative pi over 4, negative 45 degrees, and negative 3 pi over 4. Those are all the solutions on that interval, negative pi to pi. So the instructions here are to factor, so let's do that. Look, you can factor out a tangent. Well, first of all, sorry, let's back up. When you solve by factoring, you want to set it equal to 0. That way you can take each factored piece, set it equal to 0, and solve. It doesn't work any other way, okay? So we want to factor out a 5 and a tangent theta, because both of those terms have a 5 and a tangent theta that can be divided. Oh, beta, sorry, whatever. X, anything. That's what it looks like when you factor out 5 tangent beta from both of those terms and just set each piece equal to 0. So if you solve this one, you get tangent beta equals 0 after dividing 5 from both sides. So you've got to find out where tangent is 0. So remember, tangent is sine over cosine. So this is 1 comma 0. So that means cosine of 0 degrees is 1. Sine of 0 degrees is 0. So sine over cosine, beta can equal 0. Right? Because this would be tangent of 0 degrees is 0. And then same thing over here. What are we in, radians? Yeah. So pi also works. Oh, but it doesn't say or equal to pi. So we're going to say negative pi. Because if you go negative 180 degrees, then you've got cosine is negative 1, sine is 0. So tangent is sine over cosine. Okay, so we got 2 solutions out of this mini equation over here. Now over here, you get tangent beta equals negative 1. We just saw that in another video, right? To make it be negative, tangent is negative here and here. What was I going to say? Oh yeah, and for it to be 1, they need to be square roots of 2 over 2 for both places. That way, when the opposite over the adjacent, when they divide, it makes 1. So this would be 3 pi over 4, 135 degrees, and then we have negative pi over 4 for this solution down here. So this is a solution, that's a solution, these two are solutions.